Hello guys, welcome to Bugs in Code. The problem that I'm going to explain today is equal left and right subarray sum. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe the channel so that you get notified when I push a new video. Okay, so let's get started. Here is the problem statement and it says that you are given an array A of n positive numbers. Your task is to find the first index in the array such that the sum of elements before it is equal to the sum of element after it. Okay, so array is following one based indexing. One example is given here. Let me explain the problem with the example. Okay, so the example says that we have an array which is having elements 1, 3, 5, 2 and 2. Okay, and now in this array we have to return a particular index for which the sum of elements before it is equal to the sum of elements after it. Okay, so now if you see this index, then you will find that the sum of elements before this is 4 and the sum of element after this is 4. So here 0, 1, 2, but since it is following one based indexing, so 2 plus 1, which is 3, is going to be our output. So you can see that 1, 2, 3 and 3 is going to be our output here. Now I hope you guys are clear with the problem statement. Let me talk about the solution now. Okay, so after looking at this problem, the first approach that will come to your mind is, hey, if I have an array like 1, 3, 5, 2, 2, then I can traverse each index. And for each index, let's say I'm at this index I, so I will calculate the sum from 0 to I. Okay, and after that I will calculate the sum from I plus 1. Okay, we will calculate the sum from 0 to I minus 1, and here we will calculate the sum from I plus 1 to n minus 1. Okay, so I plus 1 to n minus 1. Now in worst case, again the complex this loop will run of n time in worst case. Okay, and now since we are running one more loop, so it is basically nesting of loop, like for each element, for each element, what I'm doing, I'm first calculating this particular sum, so let's call it left sum. So left sum is basically the sum from 0 to I minus 1. Okay, and the right sum will be the sum from I plus 1 to n minus 1. Okay, and after that I will simply return, I will check if my left sum is equal to right sum. If left sum is double equal to right sum, in that case I have to return I plus 1, isn't it? Because here I am traversing starting from 0 and I have to return index based on one based indexing. Okay, now at last when no index is found, then I will return simply. Okay, so let's check. Okay, so if no index is found, then we have to return minus 1. So let's do it. Here we will return minus 1. Now this is the naive approach, right? If I like write this, then it is going to give me time limit exceed for large inputs, like it is an O of n square approach. Okay, now so if I have like 10 is to the power 5 in the input, then it will be n square 10 is to the power 10, which is something uh, which will show time limit exceed. Okay, now let's talk about the optimal approach. So what optimizations we can do here? Like if I talk about this array and 1, 3, 5, 2, 2, then if I'm at this point, then I'm calculating the sum from 0 to I minus 1, right? But what we can do is, if we have a prefix sum array, like if I write the prefix sum, so prefix sum will be 1 and 4. After that I will have 9. Okay, I will have here 9. Fine. After that I will have 11. After that I will have 13. Okay, now if I want to calculate the prefix sum at any point, like I want to calculate the sum from 0 to I at any point, so I can just go to that particular index and that index will give me the prefix sum. Okay, which means that if I, okay, and even let me write one more array for suffix sum in order to calculate the right sum. It is for the left sum. If I say it is prefix sum. What is prefix sum? If you guys don't know what is prefix sum, so prefix sum is basically the sum from 0 to I. So I'll start from this index, and my prefix sum of 0 will be 1. After that I will keep adding the elements in this particular, like if I have 3, then I will add this 3 to 1 and whichever value comes I will store here. After that I have 4 here and I will add 4 plus 5 9, so I will store 9 here. After that I have 2 here, so I will store 9 plus 2 11. After that I can see 11 is present here, so 11 plus 2 is again going to be 13. So this is how we fill a prefix sum array. Similarly, the case for suffix sum array, if it is suffix sum array. So for this the case is totally reversed. I will start from the back because it is going to give me the sum from like this point to the I plus 1 index. Okay, so for this value will be 2. After that I will have 2 plus 2 which is 4. After that I will have 4 plus 5 which is 9. After that I will have here 9 plus 3 which is 12. After that I will have 12 plus 1 which is 13. Okay, and now you can see that this last element is always going to be equal because this is representing the sum of full array. So the sum of full array is going to be same for both the cases. Okay, now at I will do something. Since I have the prefix sum and suffix sum array, so I don't need to calculate the prefix sum and suffix sum again and again. So as rather what I will do is I will start a loop for I equals to 0, I smaller than n and I plus plus. In this loop, I will check only one condition. Since, see, if I'm at this point I, then I need prefix sum of I minus 1, isn't it? Because I want that sum from 0 to I minus 1. So I will check if my, okay, let me change the color. So if my prefix sum of I minus 1 is double equal to suffix sum of I plus 1, in that case I have to return I plus 1, isn't it? Like you can see that I want the sum from I plus 1 to n. So this particular index will give me sum from I plus 1 to n because you can see that this is having 4 value and the sum is also 4. Okay, fine. Same for this case as well. So this is how we are going to solve this problem. Now you can see that our task is reduced. Like here we are not doing any of n traversal inside this loop. So the complexity of this is going to be, okay, at last I have to return one more value which is minus 1. At last the complexity is going to be O of 1 n. Okay, so this is the time complexity. What about the space complexity? Space complexity is again going to be like space complexity will be here O of n, because you can see that we are using an extra array to store prefix and suffix sum. So should we implement this? Let's implement this. Okay, so I have the problem here. What I'll do is I will start first of all I will make an array. So I'm going to implement this in Java. So I'll make an array which is prefix sum. If you are a C++ coder, then you don't need to be worried because I'm also going to provide the C++ code as well. So here I have the prefix sum array and I'll make a suffix sum array as well. So it is going to be okay. Now I'm simply going to calculate the prefix sum array, but I'll start from 1. There is a reason I will tell you. So here prefix sum of I is going to be prefix sum of I minus 1 plus current element. That's what I told you. After that, I'll start a loop from n minus 2. This is basically starting from the back. And here I will change the suffix sum. Okay, let me write here. Suffix sum of I is going to be suffix sum of I minus 1 plus. Okay, here I will write I plus 1 because I am starting from the back. And here I have to make it prefix sum. Okay, fine. Now I can simply, okay, but before that I have to initialize the prefix sum and suffix sum. So prefix sum of 0 should have a value which is array of 0, and suffix sum of 0 is similarly going to be like suffix sum of last is going to be last element in the array. Okay, now I have the prefix sum and suffix sum array, so I can simply do something like I equals to 0, I smaller than n, and for each element I am going to check the same condition, like if my prefix sum of I minus 1 is double equal to suffix sum of I plus 1. In that case, I have found left sum and right sum equal, so I'll return I plus 1. Else, I'll return minus 1. Okay, so let me check this whether it works or not. Let's see. Okay, so it's showing array index out of bound error for which particular case? Okay, so I have to start from 1 here and I'll end, because if I'm at 0 then it will show array index out of bound, and similar case for this and suffix sum. Okay, now let's see. Okay, it's working for example test case. Let me submit this. Okay, so it's showing wrong answer. Why? Because if I have size as equal to 1, in that case I have to return like the first index. Why? Because for if I is equal to 1, then this is again going to show the same error, so I have to handle that case separately. Okay, now let's see whether it works or not. Okay, so now it's working. You can see that it it got accepted. Okay, now this approach is the problem with this approach is it is using extra O of n space, but we can like avoid this. Let's see what optimization we can do. Okay, so we were using extra O of n space, but interestingly we can do the same thing by using just like O of one space. We can do the same thing in O of n space, one space. Let's see how. If we have the array, like if I have an array which is having element 1 3 5 2 2. Okay, so instead of using a prefix sum array, like instead of using a prefix sum array to find the prefix sum at each point, I can use a variable. Okay, and it will give me the prefix sum at each point. Okay, and now if I'm at this point, so my prefix sum will be 1, and after that when I come to this point, then prefix sum will be 1 plus 3. At this point prefix sum will be 1 plus 3 plus 5. Okay, so I will do something like prefix sum like p sum plus equals to a of I. This is my first step for each for each index, like for each I, for each index I in the array. Okay, and now my first step will be to increase the prefix sum. Okay, and what about the suffix sum? So I'll say something. I'm saying that I can calculate the suffix sum using the prefix sum. How? If I have the whole sum of the array as total sum, let's call it sum. If I have the sum of whole array, which is 13, okay, and if I have the prefix sum till this point, so I can simply calculate the remaining part, like I can simply calculate this particular part by simply doing what? I'll simply do sum minus prefix sum, right? If I have this whole sum and if I subtract this part, then I will have this sum. So this is my suffix sum. Okay, so I can find the suffix sum. And what about the prefix sum? If I have the prefix sum till I, so I will, and at each iteration I want the prefix sum till I minus 1. So if I want to calculate prefix sum till I minus 1, then I will do uh, prefix sum minus a of I, right? So I will check this condition. If my prefix sum minus a of I is double equal to sum minus p of sum, in that case I can simply return I plus 1. I hope this idea is clear to you. Like, we are calculating the suffix sum from the prefix sum itself, and instead of using an array for prefix sum, I'm using a variable. So each point I'm just calculating the prefix sum. Okay, fine. Now at last I'm going to return minus 1. Okay, so let me quickly implement this as well. So now I'm just going to move to the problem board. Okay, now let me remove this. So I'll remove this whole code, but I will keep this condition, like if n equals to 1, then I have to return 1. Okay, fine. Now I will have a variable which is going to store the sum, which will be, okay, so I'm directly calculating the sum here. If you are C++ coder, then you will know a function which is accumulate function, which is used to calculate the vector sum. Okay, so now for each element in the array, I will first do p sum plus equal to array of I. This is my prefix sum, and after that I will check if my prefix sum minus array of I is double equal to sum minus p sum. In that case I have to return I plus 1, and at last I will return minus 1. Okay, so let's initialize the p sum, which is initially going to be equal to 0. Now let's check it. whether it works or not. Okay, so you can see that it's working for the example test case. Let me submit this. Okay, so it's getting accepted. Now this is all about this problem. I hope the idea is clear to you and the approach, like how we started from the brute force and then we moved to the optimization. So this is the most optimal approach that we have. Now I hope the problem statement and approaches are clear to you. So this is all about this video. Thank you.